So here we go. If you say anything, it'll be on YouTube. So don't say anything too inappropriate or dumb. That's 1, 2. Okay. So sometimes I want people to raise hands. Sometimes it's fine to blurt out. I think you'll know the difference. I'll tell you if I really want you to raise your hand. But for this, blurting out's good. So of these things, which one has the biggest volume? E. And volume is just size, is the biggest one. Doesn't necessarily have the most stuff in it, or it's not the most crowded, but it is the biggest. Volume, looking at things, is pretty easy. Least volume? A. A is the littlest. Which one has the most mass? F. Now, a lot of people choose D because it looks like there's a lot in it, but if we actually count these little bits of mass, there are 12 in this one, and there are only 10 in here. So that's got more stuff in it, it's got more mass. Which one has the least mass? B. Not the smallest, but it's only got one little bit of mass. The one with the greatest density? D. These are the most crowded of any of them. And this is probably the trickiest one. Which one's least dense?
C.
C. If you had trouble with C, what you can do is just think of these as being a house or something, and break them up into all the individual rooms that these little dot creatures would be living in. These would have the most space. They'd have the most. This one has the most space to itself. This one has the most space to itself compared to that, or even compared to this. So these are most spread out, the least dense. And if you were to throw them all in a bunch of water, which one would bob up and float the best?
C.
C. So I didn't add this on last time, but density, another thing that I would add to the definition, density is sort of it tells you how likely something is to float or sink. So I'm just going to say more dense means more likely to sink. If you're trying to figure out if something became more dense or less dense, that's a good test to use. Just ask yourself, well, is it going to sink better or float better now? And that'll help. Which one has the greatest weight? This was tricky for last class. Which one's heaviest? F. Because it's got the most stuff. So the answers to 7 and 8 and 11 and 12, they're going to be the same. Up here, the force of gravity pulling an object toward a planet. I'm going to modify that now. I'm going to change it to, you don't have to change it, but I'm going to change it to an object's mass. So what gravity does is it pulls two masses together. The more mass you have, the more gravity pulls you toward another mass. So the more mass you have, the more weight you have. The less mass you have, the less weight you have. More mass means more weight. Except when? When would adding mass to myself not change my weight at all?
In a vacuum.
What's that?
In a vacuum.
Not in a vacuum necessarily. We've got a bell jar that I'll bring in or bring down from upstairs, and I'll pump all the air out of it, and that'll be pretty much a vacuum. If you were in there, it would do bad things to you. But you'd still have the same mass unless you burst and started leaking. But so when would adding more mass to a person not change their weight? Yeah, Jan.
When you're in space and you have no weight.
Exactly. If there's no gravity, then you can have all the mass you want, and you're going to have no weight. So mass and weight are very similar. More of one means more of the other, except when gravity's changing, and that things are going to change there. So back to this. The least weight would be the one with the least mass. B would weigh the least. And 13, if you did that, the asterisks above are above because in special circumstances, all the objects can have the same weight. We just talked about this. When would they all have the same weight?
In space.
They'd have the same weight when there's no gravity because they would have no weight. So when there is no gravity, they would all have 0 weight. So, same. And I just noticed I'm kind of looking at my notes from A1 and 2. Something I forgot to share with you, I think, was, did I share this little thing here? I was telling them that this would be, if you're ever looking for a tattoo, I don't believe in getting tattoos myself, but if you're really geeky and you want a cool geeky tattoo, I recommend that one. It has a hidden message. Do you know what it is? Other than you love density? I'll give you a hint. So this hidden message is also provided more directly farther up the page. There we go. So I wrote this twice. It's somewhere else on the page too, especially this part. Can you find it in a different place?
Oh,
on the
it's
page?
mass divided by volume.
Yeah, that's the formula for density. See the formula for density
Oh,
there?
yeah.
Density is
Mass is the top of the
mass divided by volume.
So,
Isn't that clever? I didn't come up with that. It's clever and cute. So it'd be a great tattoo if you're looking for one. Okay, moving on to this stuff. So we're going to do this first thing together, and then I'm going to have you work on these other ones individually, and then we'll come back together to compare answers. But first, I'm just going to explain what I'm asking, what I'm looking for, and go through this. So at the top, it says, read the descriptions below and decide whether each property increases, decreases, or stays the same. I used to use arrows going up, arrows going down, and equal signs, and I kind of liked that, except the problem was when density was going up, I had an arrow going up. But when things are getting more dense, what do? Do they float or sink? So it got weird having arrows pointing up when things were sinking. So I dispensed with the arrows. Now I use plus signs, minus signs, and equal signs. So in this case, we've got a dry towel, and it's going to be squeezed. So I'll take this dry towel and do that to it. So the question really is, during that process of the towel going from this condition to that condition, what's happening to its mass? What's happening to its volume, its density, and its weight? And I want to say that there are a lot of different ways to answer these questions. And that's partly why I left space off on the blank. So if we interpret it a certain way, we can explain it, what we meant. So what do you think? First one, when I squeeze it, what's happening to the mass of this towel? Staying the same because I'm not adding any stuff to the towel, I'm not taking any stuff away. Does that seem reasonable? It's got the same fabric as before. But I have to say, if you're like me, I was kind of a smarty pants when I was in school. I was always trying to come up with exceptions to everything the teacher would say. You really could say that the mass of this towel is changing if you wanted to. It's either gaining or losing something. Is it gaining something or losing something if you're really picky? Losing what? What came out of it when I squeezed it? Air. So if you consider the towel to be like a sponge, it's got little air pockets inside, and it's a nice fluffy towel, and it feels good, and it's soft. The reason it's soft is because it's got little air cushions inside it. And if you squeeze it really hard, you can make it hard by making the air come out. So if you wanted to, you could write minus next to mass. But then you need to say air came out of it. But we don't have to do it that way. Maybe I'll do both over here. The point is just to get an idea of what all these things are, how they change when you do stuff to stuff. So I'm going to say the mass stayed the same. And my explanation, which you can choose to write everything that I write, or you can choose not to. I write this much because I think it'll help you learn. If you don't want to write it and you don't understand it, you do that at your own peril. If you don't write it and you don't need to, you're probably okay. But I'm leaving it up to you. I'm not going to check your notes and say, oh, you didn't write that down and take it off points. I won't do that. So my explanation here is nothing is added or removed. And if you wanted to, you could say, a little bit of air comes out. But you don't have to. That air doesn't have a whole lot of mass, but it does have a little, so technically I guess it would lose mass, unless you define the towel as just the cotton, and then it doesn't change. All right, this next one, this is much more straightforward. When I squeeze the towel, what happens to the volume? Gets smaller, definitely. So the volume decreases, and my explanation for that would be that it gets smaller. So whether you write this or not, you should know this. You should know why you're doing this. I think these are going to be most important in the cases where my answer is different from yours. And if you got it wrong, you should write something down over there to remember what my reasoning was. Okay, so how about density? Is it more dense or less dense now? More dense. So you could say it got compressed. That makes things more dense. You could say it's got the same amount of stuff in a smaller space, so it's more crowded. There are a lot of ways to describe that. I'm just going to say density went up because it was compressed, but you could say the molecules are more crowded. You could say mass divided by volume is now a bigger number because you have the same thing divided by something smaller. How about the weight of it? Did it get heavier or lighter?
Same.
Weight, assuming that mass stayed the same, the weight is also going to stay the same. So I'm going to write mass stayed the same. And if I were going to give a really complete answer, which I'm not, I would say the mass stayed the same and gravity did not change. That really covers everything. Because if the mass stayed the same and gravity changed, then the weight would change. These next few, I'm going to have you do them. You can think about them, talk to your friends about them. You can ask me. This isn't a test. It's just a chance to learn about this stuff. But I want to explain what they mean before you start. The one about the paper, this is what it's saying. You have a piece of paper like this one. You assume it's just ordinary copy paper. This is the paper before. This is the paper after. So the corner is no longer part of the paper. If you measured the mass, volume, density of the weight, and weight of the paper before, and then you did it again now, what would those four things do? Number 16 is just about this balloon. I'm going to inflate this balloon by mouth. And if you look at the mass, volume, density, and weight now, and then you do that again after I inflate it, how are they going to change? The next one is about a moon rock that's taken back to the Earth, or taken to the Earth. So you go to the moon, you pick up a rock, and you put it on your little shuttle, whatever it is, bring it back to the Earth. And when you're on the moon, you measure all these properties. When you're on the weight, you measure them again. How do they change? So do those. If you want to keep going, the rest is going to be your homework. But we'll at least go over these three together, and then we'll do the submarines after that. The rest will be for homework.